Hello friends, in this video we are going to discuss about the D flip-flop. So on completion of this topic, the students will be able to find out and explain the combination logic and also the flip-flops which are used between the sequential and the combinational logic. So first let us see about the D flip-flop. So as usual we know about the flip-flops. Here the toggles which we are connected to the D flip-flops will be keeps on changing the enable button from enable and enable bar. So in this case, the design which we are used to create 2 years ago, there was a silence change in the FPGAs and also this SRAM process improvements and geometry shrinks increases the speed. So normal variation that occurs between the wafer lobs and my design which pauses a timing simulation test but fails in circuit. So the timing simulation uses the worst case delays and actual mode level conditions are usually better. So the design which we are created in this will be processing the improvements and the geometry strings which increases the speed. So this design pauses a timing simulation test but fails in circuit. And this uses the worst case delays. Actual board level conditions are also usually very better. And these cases which we are using can be geometrically shrinks the cases of the major things which the design passes a timing simulation test but fails in the circuit. And the traditional clock divider which here we are using is clock and clock bar. So the buffer which we are using for the clock 1 will be first buffer and for the clock 2 will be the second buffer. This introduces the clock skew between the clock 1 and clock 2 and also uses an extra buffer to reduce the skew on the clock 2. When we are going to the traditional clock divider, this introduces the clock skew between the clock 1 and clock 2 and also uses an extra buffer to reduce the skew on clock 2. When we used to avoid this clock sketches, this can be reduces the same condition, and also when this input which we are given to the D flip-flops, it changes the buffer from 1 to 2 so that the enable button from the output will be given as an input to the next buffer. So this can create the same function and also create without any glitches on the circuits. Sometimes there may occur some delays or sometimes it may be creating some changes in the delay lines, and also the propagation of the delay will be changing based on the inputs which we are giving on the analog signal. So that first when we are given to the 1011 means then the input keeps on changing based on the clock pulses. There will be extension in so that the enable button can be easily changed. So here this is the coding for the synchronous flip-flops. So first we are giving always pause at clock or pause at reset. If we reset q is equal to 0, then synchronous means here what we are giving in this side q equal to 0 means this side it is q is equal to 1. Q specifies on the D flip-flop, difference between the synchronous and the asynchronous D flip-flop. Thank you.